One second, please. Yeah. Now let me share my screen before going further. One second. I hope my screen is visible. Can anyone confirm that, please?
Yes, it is.
Okay, thanks. Now let me go to here and yeah. Now what I want to show you before before going to the course thing as just an introduction out of me. Actually, my name is Shiva, so I have overall uh, 8+ years of experience. So I work with multiple technologies in the market, so like in the industry, I mean to say. So AWS is the one thing, and I also work as DevOps engineer. DevOps contains, as you know, many tools and technologies like like Jenkins, Terraform, Kubernetes, Python, Docker, shell scripting, and yeah, and I also work with microservices based applications with the help of Java and Spring Boot framework, and Groovy with the help for developing shared libraries for Jenkins, actually. So that's the thing. I hold multiple certifications. Oh, here are the one: AWS Developer Associate, and Certified Kubernetes Administrator, and Terraform Associate is my certifications that I hold as of now. Okay, that's my short introduction. So let's go to the course requirements. Actually, it's actually 7 to 8 actually. So that's the thing. Now, what are the prerequisites that is required for you to join in this course is like we are going to start this course from very scratch, very scratch. We are going to see. I will be going you through the course content so that you will be able to know from where we are starting this course from. We are going to start this course from very scratch so that it will be understandable for everyone in the class. Actually, it is designed by keeping in mind who like the fresher as well as the experienced people. Okay, so that's how the course syllabus is designed. Actually, now your only one requirement is the AWS account that you need to be created, actually, because if we need to install the Kubernetes clusters and the Docker software, so for that reason you need to create an AWS account. Because if you want to install Docker, you in your local machine may be with the other applications, or your local machine means your local laptop, maybe with your less amount of resources. That means less amount of CPU and less amount of RAM, so that it can affect any other applications if you install Docker in your local laptop. So that's the reason, one of the reason I want to suggest you people to create an AWS account, to create and install your Docker or the Kubernetes clusters there in the AWS account. Okay, that's how the creation of the AWS account I'll be showing in the class. No problem with that, actually. So that's a creation of the AWS account you need to as a required as a prerequisite. But even though you want to install your Docker in your local machine, you minimum requirement of your machine laptop, that should be 4 GB RAM, because that requires minimum requirement is this one, because Docker is a huge software where that takes high amount of CPU and high amount of RAM, actually. So I suggest not to install in your local machine. I suggest install in the AWS, actually. So whatever that we discuss in the class, that will be taken in the AWS account. Okay, for the if you are using Azure accounts also it is same, but if you are using GK is also it's same. Ultimately, for the installation of Docker, you can use whatever cloud provider it is, you can use that, but only AWS account will be shown here. Okay, that's the thing. Now, who can join this course? Freshers and experienced people who are the developers, testers, DevOps aspirants, Linux admins, DB admins, and non-IT students. Okay, so because as I've already mentioned, because this course is designed by keeping in mind the freshers as well as experienced people, so both should be benefited. So that I have designed this course so that you can anyone able to join this course, any graduates from the colleges also join this course. What you're getting the benefits actually for joining this course. Actually, doubt clearing sessions will be getting, and fully documented notes of whatever the things we have discussed, and full hands-on sessions, because whatever we are going to discuss in this course will be full hands-on. Okay, full hands-on, that means we are going to make our hands dirty in order to complete this course. And actually, so 5 different projects that we are going to discuss: one project with the Docker and the Docker Compose, and the other projects with the Kubernetes. Okay, one project with the Helm, one project directly with the Kubernetes resources, other project with the directly with the Argo CD, and other project with the like Kubernetes dashboard and related things. Actually, if time possible, I'll also include our Istio as service mesh, but let's see what will happen in the future. Actually, now you are going to get the interview questions which are required for your cracking the interview, and we will be starting this course from very basic level. Okay, from very basic level, and we'll be completing this course at very advanced level, and so that everyone will be understanding everything. Actually, now that's the thing. What's the timings for this course is 2 hours class from every weekend, that is 8 a.m. to 10 a.m. actually, because as of now, today and tomorrow will be from 9 a.m. to 11 a.m. but actually this class will be shifted to 8 a.m. to 10 a.m. every Saturday and Sunday, every weekend. Actually, that's how it is. Now I will be going through the course content, because you need to know what you're going to learn in this course prior itself, so that you will be like getting some knowledge on that. So that's why I'll be going through the course content now, latter point of this slide, or the latter point of this document. So that's the thing. Contact information, because if you have any non-technical things like having the any access permissions issues and having any things, okay, you can contact these mobile numbers and the Gmail ID, so that they will be clearing your doubts and they will be clearing your problems. Actually, so these are the things. So these are things. The ultimate thing from this document is the AWS account that is required for in order to create the servers, actually, in order to deploy our applications as a as form of Docker containers. I'll be showing how to create a AWS account. That's the thing. Okay, now let's go through the course content, what you are actually going to learn in this course. This is a course content. If you are able to see, yeah, I think you can able to see, this is a course content that we have. Now when you are going to look at this course content, you can see from where we are starting the course, from what is SDLC. You can understand from where, how much basic level we are starting the course. Okay, what is SDLC, and from there we are starting in this point of a section. We are going to discuss about the SDLC process and the importance of Docker, the importance of Kubernetes, the importance of DevOps in the industry, and how the Docker is evolved, how the Kubernetes is evolved. Actually, now because previously the people used to deploy their applications as part of physical machines, and what are the disadvantages that the people has faced if they deploy the applications on as part of physical machines, why the virtualization is evolved, what are the disadvantages that are there with the virtualization, how the Docker is evolved, what are the disadvantages that we have with Docker, how the Kubernetes is evolved. In such manner we are going to understand in this part of section. Actually, this is that section as just an introduction that we are going to give. Okay, that's the thing. Now, and the other section we are going to discuss about the Docker terminology. Okay, Docker terminology, like Docker, what is Docker container, what is Docker host, what is Docker client, what is Docker daemon, what is Docker registry, why we call it as Docker registries, why what are the different types of Docker registries that we have, and Docker images. And we are also going to see a developer tool for Docker Compose. Okay, Docker Compose is the developer tool where the developers uses that tool in order to automate the creation of Docker containers. If you want to create 50 containers, you, instead of like spending a lot of more time in order to run 50 different commands in order to create a 50 different containers, you will be writing all the related information in one Docker file, Docker Compose file, I mean to say, and you will be executing that Docker Compose file with one command, and all the 50 containers will be deployed at one go. Actually, such kind of tools, that's a powerful tool that we have. We are going to discuss. For that tool, we also need to have the knowledge on YAML syntax. We are going to do that. Okay, YAML syntax will also be covered. So Docker commands, Docker containers, terminologies of Docker, Docker Compose, everything part of this section. Actually, now Docker deep dive. Okay, in this part of section, as I already told you, you need to understand the flags that we are going to use along with the commands. What is flag? You are going to, like, we are going to see some like some of the some of the words I'm using might be technical or hearing for you for the first time. Please bear with me. It will be very clear in the doc course actually. So that's the thing. Now working with Docker images, and we are going to see 3-tier architecture. Now see, we have two different microservices, right? So these two microservices need to be communicated with each other with the help of REST APIs or whatever the protocol they follows. Okay, they need to be communicated with each other in order to serve as an whole application, right? How to establish a communication between these two microservices in the Docker actually, that we are going to see as part of this using -- link option and Docker Compose, and everything as I already mentioned is part of practical sessions actually. Like means it's we are going to make our Docker like hands dirty in order to complete this course. Okay, that's the thing. Now creating custom Docker images is a part next section. Like you will be having your own applications, right? Spring Boot application or the Java application or sorry Python application or the .NET application. How to convert that application to Docker image? Okay, how to create a Docker image out of your Docker application, Docker out of your Spring Boot application, because you cannot directly deploy your code on the servers, right? That will not work. Okay, you need to perform some steps between the deployment and your development actually. So that step, like creation of Docker image, how you are going to do is part of this section. We have different keywords that we need to use in order to understand this section. We are going to use that as part of practical sessions and everything actually, different keywords and Docker file. Okay, that's the thing actually in this part of section. Now Docker volume size, Docker networking is the next section. What we are going to discuss in this section is we have two types of Docker volumes, is like simple Docker volumes or bind bounds, and Docker Docker volume containers is another type actually we are going to discuss. And the networking, we have 4 types of networks that are available with Docker: bridge network, host network, none or null. The other one is null. Okay, overlay network is used with Kubernetes. So that's the networking we are going to discuss all the practical examples. Okay, Docker registry, and what is in this part of section, how to push the images to the public Docker registry, how to push the images to the private Docker registries. So you need to store your images somewhere somewhere, right? So that you can able to use those images, right? So you are going to you are going to store the images in the registries actually. That is called registry, that we call it as all the practical examples. Now advanced concept, this is very much important for you to work in the industry, because multi-stage Docker builds is an important concept that you need to know in order to create very secure Docker images with a very less amount of size actually. So that we are going to discuss here. Multi-stage Docker builds, we are going to convert our Spring Boot application to a Docker image which is highly secure and which is highly which is very less in size actually, using multi-stage Docker builds. The industry standard will be multi-stage Docker builds, because people will be mostly using this multi-stage Docker builds. Before using this multi-stage Docker builds, you need to understand the creating custom Docker images. That is why I put that creating custom Docker images in the front actually. That's a thing. Now practical examples of multi-stage Docker builds and the projects on Docker and Docker Compose we are going to do, and we are going to perform debugging and troubleshooting of issues faced in the Docker, right? Because you people able to know what might be the different problems that we will be facing in the Docker. Okay, you should be knowing that right before itself, so that you will be understanding like where this problem has been occurred, why this problem has been occurred, what is the solution for it, and you'll be understanding in that way. So that that kind of troubleshooting we are going to do. We are going to create a problem and we are going to solve that problem, and if any problem appears in the middle of our practical sessions, we are going to solve that problems. How to find the problem also we are going to see. You need to check the logs, or you need to check the metrics, or whatever it is. So you need to perform step-by-step process in order to find the problem of that particular, whether it is a problem related to the like infrastructure means our infrastructure means our servers. Okay, whether it is a problem related to your application, you will be able to know as part of this troubleshooting and debugging actually. That's a thing. That's a end of Docker that we are going to see as part of this course actually. Now that's a thing. Next as part of next thing, so we are going to introduce, like it's a short introduction will be given for your Docker like Docker Swarm, because Docker Swarm is nowhere used in the industry, because that's only supports Docker, and we are quickly moving towards the Kubernetes. Okay, that's how that we have different organization technologies that are available in the market, that is Docker Swarm and Kubernetes. And why we are moving to Kubernetes, what are the disadvantages that we have with Docker Swarm, that we are going to see as part of this actually introduction to Kubernetes. Next thing is that one. Now Kubernetes is the next tool, that's an important tool, which is the industry standard that we are going to use, we are going to see as part of this course actually. Now that's the thing. Now what is Kubernetes, why we call it as K8s? Okay, in the Kubernetes, this is a word of Kubernetes. Between K and S, okay, there are 8 characters, that is why we call it as K8s. Okay, that's a thing. We are going to install Kubernetes as part of this section. We are going to install Kubernetes in 3 ways actually. You can decide which way to use, but I will be showing you the 3 ways, because that's the thing. Minikube way, that means single node cluster actually. Now the second way is KubeADM way. I'll also be showing you how to install a Kubernetes cluster with KubeADM way. I'll also show you how to install a cluster with EKS way actually. That's how we are going to see actually. Now we need different tools in order to install, in order to connect with the Kubernetes cluster, right? In order to visualize the Kubernetes cluster actually, that is kubectl is one of the software you need to install. Okay, that's also we are going to install actually. Now creating Kubernetes clusters with AWS EKS, with YAML, and creating like architecture of Kubernetes. Okay, so you need to understand the architecture of Kubernetes first, so that you will be able to understand what are the interactions that is happening inside the Kubernetes cluster actually. So you need to understand like what is kube API server, what is controller manager, what is etcd, what is kube scheduler, and you need what is kubelet, and where does it lies actually, what is kube proxy. So that's all the things that all the terminologies that you need to understand actually. Explanation of technical terms. Okay, as I mentioned, you need to understand the technical terms with the help of Kubernetes, because before deep diving into the Kubernetes or Docker, you need to first understand the technical terms that we are going to use as part of that technology or that tool actually, so that you will be understanding why we are calling that as this with this name actually. So that's the thing. Now, exploring Kubernetes clusters. Okay, we are going to explore. We are going to use the imperative commands and Kubernetes manifest. Actually, industry standard is the Kubernetes manifest, and we are also going to see imperative commands to install, to deploy our applications into the Kubernetes cluster. Actually, so that's a thing. Why we call it as a Kubernetes cluster? Because it's a combination of multiple servers. Kubernetes cluster is a combination of multiple servers. That's called as cluster. Actually, so that's the thing. As part of this section, Kubernetes workloads and resources, we are going to see different workloads as part of this actually. So like what are pods, what are init containers, what is replica set, what is deployment, what is daemon set. So when to use daemon set, when to use the deployments, and when to use pods, and when to use init containers, when to use jobs and cron jobs. So in such manner we are going to see when to use what with what. Suppose I have a requirement to collect the logs, to which object you need to use in the Kubernetes. You need to use deployment, or you need to use daemon set. So you will be understanding in that manner what object need to be used when, depending on your functionality that you want to perform actually. So that's what you are going to see in this course. And explanation of annotations will be given. Multi-container pods, we can have multiple containers in the pod. What is pod, what is container, all these technical words you'll be clearly understanding in the course. But as of now, bear with me, because I need to explain the course content that we are going to see in this part of this course. Okay, all the things will be practical. Okay, all the things will be practical. Okay, now Kubernetes services and load balancing. Okay, now in this section you are going to understand different types of Kubernetes services that are available actually. Cluster IP, node port, load balancer, external name, and understanding a multi-port services. Now you will be understanding the practical examples. Along with the practical examples, understanding the DNS name. Okay, each and every service, what is service, and different types of services, what is the different DNS name for that service. So you'll be understanding such kind of things as part of this section actually. Why to use service actually. Okay, that's when to use what type of service, when to use cluster IP type of service, when to use node port type of service, when to use load balancer type of service, when to use external name type of service. So you will be understanding in that manner actually. Now Kubernetes storage. Okay, in the part, as part of Kubernetes storage, we are going to see what we are going to see is different types of storages are available: persistent volumes and persistent volume claim, static volume provisioning, dynamic volume provisioning. And what is dynamic volume provisioning is based on your requirement. Based on your requirement, a volume, what is a volume? Volume is something like it's a storage that will be created in the AWS account, EBS volumes actually. So that will be automatically created based on your requirement. Okay, that kind of setup we are going to do as part of this Kubernetes storage actually. So that's a different things that we are going to see as part of this volume Kubernetes storage actually. Now configuring Kubernetes workloads. Okay, configuring Kubernetes workloads. You need to configure your Kubernetes workload. Your Kubernetes workload means your applications actually, how to configure. Suppose you want to give your application that your application requires 2 CPUs and 2 GB memory in order to run perfectly without any problem. How to configure that in your Kubernetes manifest file, and how to configure your secrets. Suppose your application want to connect to MySQL database, right? So how to configure that secrets? Like you need to, your application need to know username and password and the MySQL endpoint in order to connect to your MySQL database, right? You need to configure those configurations in your like application. How you are going to configure those kind of environmental variables for your application that you want to run in your Kubernetes cluster. All such type of things that we are going to see in the help with this configuring Kubernetes workloads. We are going to configure with liveness probes and readiness probes and health, like for the health checks actually. So that's the thing. The interesting part is this one, horizontal pod autoscaler is something like, suppose your application has been deployed to the Kubernetes cluster, and what is the requirement here is, suppose today your application is newly deployed to your Kubernetes cluster and it is new to your market actually. Now your application may be encountering only 100 requests today, but tomorrow your application has been popular and your lot of people accessing your application. That means the traffic that is coming to your application will be also be increased, right? So if the traffic is being increased, your application should be capable enough of like accepting that much amount of traffic, right? So what this horizontal pod autoscaler does for us is, based on the amount of traffic that is incoming, traffic that is coming to your application, the application will be scaled, right? The application will be scaled. That means the more number of applications will be launched in the Kubernetes cluster based on the traffic, that is based on the incoming traffic actually. That's an interesting part. Okay, that's the thing. Now liveness probe and readiness probe and startup probe is for the health check that we are going to see, and configuring Kubernetes pods with image pull policy. So we have something called image pull policies that we have. Okay, always if not required and never, something like that we are going to see actually. Now commands and arguments, explanation of namespaces, practical examples. Okay, something, all those things. Now scheduling, as part of scheduling what we are going to see is, like scheduling means deploying. So we have, I have told you Kubernetes cluster is a combination of multiple nodes, right? Multiple servers. Suppose I want to deploy my application on particular server. I have 3 servers: server A, server B, server C, right? So I want to deploy my application only on server C only. So you should not deploy other 2 servers. You can do such kind of perform, like you can do such kind of functionality as part of scheduling. As part of scheduling, what we are going to see is about like taints and tolerations, node affinity, and pod affinity, pod anti-affinity, and manual scheduling the applications based on your labels and selectors. So such kind of scheduling things we are going to use as part of this scheduling things actually. As I've already mentioned, you need to yeah, like everything will be practical actually. That's the thing. Now as part of security is an important things for your working as well as for your interviews actually. People will be asking, what is role based access control? Have you worked on that role based access control? What is role based access control? So based on the role, suppose you have created a Kubernetes cluster in the AWS account. Suppose you are a developer, or you are an administrator who are managing the Kubernetes cluster. For the administrator, the access should be entire Kubernetes cluster, or whatever the actions you want to perform, you should be able to perform all the actions on the Kubernetes cluster, because you are an administrator, right? So, and who are the developers? They should be only able to view the applications on the Kubernetes cluster, because they will be able should be able to know whether the application is in the in the Kubernetes cluster is properly working or not. They should be able to only view. If the testers are there, they should be only able to perform the testing on the applications. They should not be doing any other thing. Actually, such kind of, based on the role that you have, if you are a developer, you should be able to view. If you are a tester, you should be able to only test. If you are an administrator, you should have the entire access in the Kubernetes cluster. Based on the role that you have, you are going to give an access permissions to that role. Actually, such kind of RBAC, that means, what is RBAC? Role based access control. You are controlling the people in order to accessing the Kubernetes cluster, actually based on the role they have. That is the role based access control. How you are controlling? You is using service accounts, okay, roles, role binding, cluster role binding. Role binding, cluster role binding is for the people, is for the human beings, in order to access the in order to access the Kubernetes cluster. But service accounts is for the third-party applications. For suppose your Jenkins need to be deploying applications on your Kubernetes cluster, right? In that case, your Jenkins is a third-party application, right? So that Jenkins will be using service account in order to deploy the applications on the Kubernetes cluster. For the third-party applications, you are going to use service accounts, and for the human beings, in order to give access to the Kubernetes cluster, you are going to use role based access control. Okay, that part of security, you are going to also see the static pods. What is static pod, and what is .cube config file in your local that is created. It's all such kind of things that you are going to see. Now, as part of networking, we are going to use ingress controllers. Like we are going to use two different types of ingress controllers. One is Nginx ingress controller, other one is Kong ingress controller. And how to perform path-based routing. Okay, you will be able to know, if you are a developer, what is path-based routing. Path-based routing is based on the requested path in the URL. The traffic should be routed to particular microservice. So that how that is performed, how need to perform that one, we will be able to see as part of networking. Actually, path-based routing, host-based routing, and network policies, we are going to see service internal traffic policy, how the services routes the traffic to their indeed microservices, like internal microservices. So that's we are going to see that one thing, and everything will be practical. Okay, that's the thing. Now, backup and restores, how you can perform backups on the Kubernetes cluster, actually using cron jobs and jobs, and using normal Kubernetes resources, actually. So we are going to see the backup and restores as part of that. And monitoring and troubleshooting. In the monitoring and troubleshooting sections, what we are going to see, you will be able to monitor your Kubernetes clusters. Like you will be able to view workloads. Hello. You will be able to view the different workloads what are running inside the Kubernetes cluster. Like you will be able to see the pods, you will be able to see the what are pods, what are nodes, everything we'll discuss, because I need to explain the syllabus. I'm explaining all these things. So we are going to install two things. One is K9s, where you can visualize the things, and the other tool is Kubernetes dashboard, also one of the thing. K9s is the client side tool, and Kubernetes dashboard is a server side tool that you will be installing, and you will be visualizing the Kubernetes workloads which are deployed in the Kubernetes clusters, actually. And we are going to perform monitoring and troubleshooting, like what are the different problems that may occur with the Kubernetes clusters, and how to solve those problems, what are the reasons for that problems. And if you know that such kind of things prior itself, it will be very easy for you, to work in the industry. So such kind of things we are going to see, actually. Now, which application is taking more amount of CPU, which application is taking very less amount of CPU. So such kind of what see, when the resources like CPU and memory is not enough for running your applications, in the Kubernetes cluster. So what you need to do in that case, such kind of use cases we are going to perform as part of this actually. So visiting logs, describing applications, finding problems, and knowing where the problem has been occurred, whether it is infrastructure side or whether it is application side, we will be able to go know from here actually. Now, other tools, we are going to see the Helm as a package manager for Kubernetes for deploying of our applications on the Kubernetes clusters. So that is Helm actually. We are going to see different functions as part of Helm, and we are going to templatize our applications, our manifest files, and deploy using Helm charts. So we are also going, as I already told you, we are also going to see the different folder structure, okay, of the Helm, and KNS tool to manage multiple EKS clusters, and Argo CD is the important tool, okay, in the market now. Okay, Argo CD is to automate the deployment of our applications to the Kubernetes clusters actually. Argo CD is a popular tool. There is alternative to Argo CD as well, that is called Flux CD, but people will be using mostly the Argo CD, that is used to automate the deployment of our applications to the Kubernetes clusters actually. So because Argo CD will also give the some flexibility for us, there are different functionalities that are available with the Argo CD. We will be going through each one in the Argo CD thing actually. Now that's the thing. Projects on combination of Docker, Kubernetes, KNS, and Argo CD actually, and along with Helm. Okay, that's also will be there. Now, summary, and last but not least, we are going to summarize everything that we are going what that we went in the course, and we are going to end this course. Okay, this is how we are going to follow in order to like gain the knowledge from this course. So that's how we are going to see the things. Okay, any questions you have, you can ask, and we'll have any questions.
So mostly this is based on AWS uh, kind of pattern, right?
Yes, it's
Is-
based on AWS. Yes.
Okay. So does the same principles apply for Azure as well?
Yes, same principle as apply for Azure as well, because it's just creation of virtual machines as well as creation of Kubernetes cluster. That's it. Okay, that we are going to. You can use any other cloud providers, whether it is Azure, whether it is GKE, or whether it is AWS. But in this course, we are going to use the AWS. That's it. Okay, that's just creation. Everything, whatever we are going to see in this course will be common for every cloud provider. That's the thing.
So how are we going to try out practical, practical hands-on sessions? Is it we're going to have some options, trial versions, or how do you think will help us familiarize with these concepts?
Yeah, we are going to create a virtual servers for the Docker. One virtual server is needed for the Docker, but we are going to install Docker in that one. And what is virtual server? I'll tell you. But yeah, we are going to install virtual server in AWS account, and we are going to practice there. But for the Kubernetes, I am going to tell you. I'm going to tell you three ways of Kubernetes creating Kubernetes clusters. Actually, one is Minikube way, and Kubedium way, and the EKS way. Okay, so because based on your requirement, based on your things, you can decide which way you want. But all the ways which I'm mentioning, and which I'm going to use, the concepts will be same for all the ways actually. If you are using Minikube, the concepts will be applied to Minikube. If you are using Kubedium, the concepts which I mentioned, which I am going to discuss, will be applying to Minikube. If you are using EKS, the concepts which I'm showing will be applied to EKS also. Okay, if you are using any other cloud provider, the concepts will be same, but different ways of creating Kubernetes cluster. But in this course, we are going to use the Kubedium as well as EKS way. There are these are the two different types of creating Kubernetes clusters we are going to use. Yeah, that's the thing.
Yes, I have a question. When deploy Kubernetes on AWS, do you have any step to implement when it's come to the failover? Like assuming, I'm just taking one example of an application that usually we deploy it on AWS, and we do some failover in case one application goes down in one particular AZ, so we be able to route the traffic to a different AZ also. So in Kubernetes, do you have the that kind of step also in case one you deploy your Kubernetes in one AZ and this AZ fail, do you have the failover to control or to move your Kubernetes to a different AZ also? I'm just a little confused at this point.
Yeah.
How does it work?
Yeah, because this Kubernetes cluster will not be deployed in one AZ actually. So if you
Okay.
if that is spread across the AZs availability zones, okay. So in the industry, people will not be deploying Kubernetes cluster in one AZ, that will be spread across the AZs. If your application is deployed in one AZ, if that problem appears with that AZ or for that failover, Kubernetes, what does Kubernetes does is your application will be deleted from that AZ. It will be automatically moved to other AZ. If that problem appears with that AZ which you are mentioning, that will be automatically switched to different AZ or different server which is present in different AZ. So that will be taken, that failover will be taken care by Kubernetes. We are going to use something called deployments. If as part of the deployment you are going to deploy your applications, if that application is deleted, automatically failover things will be taken care by Kubernetes itself. We no need to worry about the failover things. Okay, so some failover things are there, like increasing the memory of that applications and decreasing based on the request. Such kind of failover things we are going to manage by ourselves. But AZ problem, like server problems, which that one we are going to manage by the AWS itself.
Okay, so in my understanding, the Kubernetes will be deployed in multiple AZ, right?
Yes.
Okay, okay.
Any questions? Have anyone have any questions before going further?
Also, in real time, performing a backup in Kubernetes, you said you use a cron job for it, or do you use anything like Python script to perform the backup on Kubernetes?
In real time, Python
Yes.
script which you are mentioning is part of cron job. We are going to use Python script as part of cron job in your real time. Actually, that cron job will be running at particular time. Actually, suppose you want to run that cron job every morning 8 a.m. That cron job will be running 8 a.m. If that cron job runs, your Python scripts also automatically runs. The functionality of your Python scripts will be taking the backup from the applications and storing it somewhere wherever it is required. That entirely depends on the cron job. That cron job internally contains a Python script that will be running. That depends on two actually, cron jobs and Python scripts.
Okay. Also, you mentioned couple services. Um, so I would like to know when it's come to load balancer or external name, will you be able to, when we use an ingress controller, will you
Okay.
be able to point some of the like we call it the path, like to get the path to a specific uh application with the domain stuff like that, or you're just gonna show how ingress controller work and that's it? Are we gonna do a practical implementation of ingress controller with the path routing?
Yeah, we are going to do path based routing. I have designed an application, I have developed an application for with
Yes.
two different paths. Suppose if the path is slash, okay, is slash app, okay, if the path is slash app from your URL, that will be routed to one particular microservice. And if your slash test is another path, if the user requested with slash test, that will be routed to different microservice. That we are going to see in a practical manner with the Kong as well as Nginx ingress controller. That we are going to see. That's an important thing as you need to know as
Yes.
part of networking. Yes.
And is any SSL and or TLS implementation also, or we gonna secure it or no?
Yeah, that is part of AWS. We have something called ACM, okay, Amazon Certificate Manager. That URL which will be getting out of the that one ingress controller, we can we can also integrate that with ACM. Then your HTTP URL will become HTTPS. That will be secured. But as part of AWS, we are not going to do that because we are only covering the Kubernetes and the Docker things here.
Okay, thank you.
Yeah. Any questions anyone has before going further? Yeah, if you have no questions, let me go through the course things actually. Now let me go here. 1 second. Yeah, we went through all these things, general introduction, course introduction, tutorial introduction. That's the thing. Now this is our agenda, like as part of today actually. What is DevOps? What is an application? What is SDLC? What is a server? And what is physical server? What is Docker and Kubernetes? Where does and Docker and Kubernetes fits in software release process? Actually, that's what we are going to see as part of today actually. Now, what is DevOps? DevOps is a combination of development and operations. Development, that does not mean your application development. In DevOps, what is development means is you are going to develop some scripts or some Python scripts or some Terraform scripts, some whatever Groovy scripts. Okay, to automate your regular activities, to regular tasks. Actually, that is the development that we are going to do as part of as part of DevOps actually. Now, once the development is completed and all the infrastructure is deployed, now what is operations that we are going to do as part of DevOps is, as part of operations, we are going to maintain the infrastructure by providing security, by providing regular updates to the operating system, or by providing some operation things. That all comes under operations in DevOps. DevOps is a combination of development as well as operations. Development is not an application development, but it's a development of scripts in order to automate the regular tasks. And you'll all be able, you also should be knowing the application functionality as part of development. And the operations, the maintaining of the developed infrastructure, created infrastructure, will be coming under operations actually. So that's a DevOps that we call. So we have different tools in each and every stage of DevOps. Okay, but we are going to see Docker and Kubernetes as part of this course. Okay, that's the thing. Now let's go down. Now, what's an application? Application is simply known as a website, right? We are in your regular life, we are going to access different applications like Redbus or Amazon or Flipkart or any other applications. Okay, so lens card, so something different applications that we have, right? So those are called applications, right? So that's the application. Now, how the people will be developing, there are many methodologies, but as part of this we are going through SDLC process. Okay, how the applications are developed in the industry. There are 6 phases in SDLC process. One is analysis phase or the requirements phase. Like in this phase, in order to develop an application that is given to us by the client, what the industry does is they will be collecting the requirements. Like what they does, they'll be knowing the requirements, how many people needed to in order to complete this project, how many teams needed, what are the resources needed, and all that such kind of requirements will be collected as part of this requirement phase in SDLC. Okay, now in the design phase, we will be having the system design that need to be performed. Okay, in the design phase actually, there will be UI UX designers will be there. They will be performing the design of their application, front end application, and the back end applications will be using the system design in order to design that one. And yeah, that for a simple example, let me tell you. Okay, in order to log in to any application, like you need to enter the username and password, right? You need to enter the username and password. So if you want to enter the username and password, you need to have that screen to enter that one, right? The text boxes should be there on that screen. Now, where that text boxes like entering username, entering password should be appeared on the screen, whether it is on the top of the screen, whether it is on the bottom of the screen, whether they should be on the middle of the screen, or left or right. So that kind of design will be performed in this design phase. So that kind of decisions, okay, will be taken in the design phase. Now this design, which is happened in the design phase, will be given to the developers, whether it is a front-end developers for developing front-end applications or the back-end developers for developing back-end applications. The developers will be there, and these developers, what they'll do, they will use some programming language. If the backend, they may use Java, .NET, or Python based on the requirement. Okay, so they'll be handling the programming language. They will take one programming language, and they will be developing the design that be given by the design phase. They will be developing the functionality of the application. Okay, that's the thing. If that development is part of front end, they may use React, JavaScript, or anything. Okay, that's kind of the development that they do. And in the development phase, people will also be performing unit testing. Okay, unit testing, they'll be using some in the Java, we have different frameworks like JUnit, Mockit, and PowerMock in order to write unit test cases for your application. So unit testing will also be handled by the developers only. So that's the thing. In the testing phase, once the development is completed, in the testing phase, testing team will be there. They'll be performing performance testing and regression testing, A by B testing, or different types of testing strategies. They'll be performed on the developed application. Actually, testing will be performed there actually as part of testing phase. Now in the deployment phase, this is an important phase where our Docker and Kubernetes fits. Actually, deployment phase is where our Docker and Kubernetes fits. Actually, in the deployment phase only, our Docker and Kubernetes comes into picture. Once the development and the testing is being completed, that our applications we are going to deploy on the servers. Actually, how we are going to deploy on the servers? Using Docker and Kubernetes as part of this course. Actually, so that's what we are going to see. That's the deployment phase. Maintenance phase. In the maintenance phase, what we are going to see is we are going to maintain the application. Suppose you want to a new version of your application has been released, you need to deploy that application to that server, right? So you in that maintenance phase, that will be performed. Actually, so such kind of security updates, as I mentioned, and like software updates, application updates, so operating system updates. So such kind of maintenance we are going to do as part of this software development in the maintenance phase. Now the important phase for us, because our Docker and Kubernetes comes under deployment phase of SDLC process. We are going to deploy our applications as Docker containers and in the Kubernetes cluster. So that's important phase for us. Okay, that's the thing. Now that's a deployment phase. Now what's a server, right? Server is something like it's a physical machine. Okay, it's a machine where we will be deploying our applications on that, actually, so that people in the around the world will be able to access that application. So that is server. Server is a physical machine, like is a machine where we deploy, where we put our applications, and so that the applications will be accessible around the world. That is a server. Actually, now where does Kubernetes, Docker and Kubernetes fits in SDLC process? Is they are part of deployment phase of SDLC process. Now what are physical servers? The servers which we can touch and feel is called physical server. Like in the previous times, in the previous, where the virtualization and the Docker is not evolved, industry is going to use the virtual servers in order to deploy their applications on them. Actually, so what are the physical servers? We have different disadvantages that we have with the help of physical servers if you are going to use them. So we will be listing now what are the different disadvantages that we have with the physical servers and why we went to virtualization. So let's discuss one by one. Okay, now let me go here. Let me remove all these things. Now suppose let's think this is the physical server. Okay, this is the physical server. For this physical server, we will be having some amount of RAM and some amount of CPU, right? So let's think this is the physical server. Let me write it here, physical server. Okay, let me think this is a physical server. This physical server has 10 CPUs, 10 CPUs and 10 GB RAM. Okay, 10 GB RAM actually. So this is the CPUs and 10 GB RAM, right? So if I have deployed an application on the physical server, this is my application that is deployed on the physical server, and my application only requires, let me put the requirements for my application. This is application. My application requires 1 GB 1 GB of RAM and 1 CPU is required. Okay, 1 CPU is required. Now, what about the remaining 9 CPUs and 9 GB RAM? 9 CPUs, let me put it here, 9 CPUs and 9 GB RAM. Now, this is the remaining resource, right? 9 CPUs and 9 GB RAM has been left out, right? So, because of this reason, first reason, because this reason is the first reason why we went to the virtualization. First reason that we have, let me put it here, disadvantages of using physical servers in order to deploy applications. Okay, in order to deploy applications. So now let me increase the font size. So this is the thing actually. Now, first disadvantage is that we have is the resource wastage. Okay, resource wastage. Now, if you notice here, I have deployed my application. My application is only required. My application only require 1 GB and 1 CPU amount of. These are the only requirement for my application, and the physical server has 10 CPUs and 10 GB RAM. Okay, right memory. That means so I am only using 1 CPU, 1 GB and one CPU. Now this is the resource wastage that we have. 9 CPUs and 9 GB are idle and they are not being used. Okay, so for this also I need to that's the resource wastage that we have. What is the second disadvantage that we have is, suppose I want to deploy multiple applications on physical servers. Okay, multiple applications on physical servers. Suppose I want to deploy multiple applications on multiple physical servers, so I need to buy all those physical servers, right? So I need to buy all those physical servers and install somewhere, right? So for that I need to spend huge cost, right? Huge cost I need to spend, huge cost I need to spend uh, to buy that physical servers in order to deploy multiple applications on the things. Actually, that's the cost. Why cost is more if you deploy the applications on the physical servers. Now, what is the third disadvantage that we have if you deploy your applications on the physical server is the high maintenance. Suppose if you want 100 servers and you have taken a big room and installed 100 servers on that room, in that room, and you need to provide the air conditioners. A separate team should be there in order to maintain that servers, and is different maintenance. Active power supply should be there, air conditioner should be there, big room should be there, and that are all the maintenance activities that you are going to get actually. So if you are deploying the applications on the physical server, there will be a huge maintenance that you will be having in here. Actually, the third disadvantage is huge maintenance that we have. That is the third disadvantage that we have. Now, suppose the other disadvantage that we have, suppose if I if I terminated this physical server, if that physical server is deleted or down by any choice or by mistake or by some problem. Okay, some problem has been occurred to this physical server and this physical server is down, right? If the physical server is down, my application which is running inside the physical server will also be down, right? So that does not have disaster recovery mechanism. Okay, so because disaster recovery mechanism means if one physical server is down, the other server need to be created automatically without our manual interactions. So that is the disadvantage that we have in case of physical server. Now, this is a fourth disadvantage: no disaster recovery, no disaster recovery mechanism that we have with the physical server. There are many disadvantages like this. Okay, let's stick to this. There are the 4 disadvantages let's think of, and these are the disadvantages that we have seen actually. Now that's the disadvantages that we have right now. Because of these disadvantages that we have with the physical servers, we went to virtualization or virtual servers. Now what is virtualization, what is virtual servers? Let's think one by one. Now let me take, this is one physical server. Okay, this is one physical server. Let me go here, let me take this box and let me put it here. This is my physical server. Okay, this is my physical server. On this physical server, let me take control Z, and this physical server has, let me put it here, this physical server let me take, this physical server has 10 CPUs, 10 CPUs and 10 GB memory actually. So this is the physical server that we have. Once again, CPU and 10 GB memory. Now on the physical server, what will be there? What will be there? There will be a operating system that will be installed. Okay, whether it is any operating system, Linux or Windows or whatever it is, operating system. Okay, that will be installed on this physical server. Now on the top of operating system in virtualization, what will be there? We are going to install, people have installed something called virtualization software. There is a different virtualization softwares available in the market, like hypervisor, Hyper-V, VirtualBox and VMware. These are the different virtualization software that are available in the market. Let's take the installed virtualization software is hypervisor. Okay, hypervisor. What is the functionality of hypervisor? I'll tell you, but yeah, they have installed virtualization software on top of operating system called hypervisor. Let me take this line and put it here. Okay, this is a hypervisor that is installed. What is the functionality of this hypervisor? Is this hypervisor will be helping us to create multiple machines as part of this physical server or physical machines. Now how the hypervisor will be helping? We can create multiple machines like this. This is one machine, one machine. Let me put like this, and this is a second machine, and this is the third machine that is there with us. Okay, these are multiple machines. So this hypervisor or virtualization software will help us to create multiple machines in one physical machine, physical server, or multiple servers in one physical servers actually. That is a functionality of the hypervisor. Okay, these servers, these multiple servers within the physical server is called virtual server or virtual machines. Okay, let me put it as virtual VMs. Okay, VM. Okay, now this is the another thing. Let me take VM. Okay, now this is another thing, that is VM. Okay, now see, this hypervisor will help us to create multiple servers on one server, that is virtual server or virtual machine. Now the 10 CPUs and 10 GB RAM or 10 GB memory that we have will be spread across this multiple virtual servers. Let's think, this first virtual server has 3 CPUs. Let me take that as 3 CPUs. Let me take this and put it here. The CPU and 3 GB memory. Okay, let's think this. Okay, let me copy this and let me put it here. Okay, let me put it here as well. Okay, now each virtual machine is allocated 3 CPUs and 3 GB memory, and this 3 CPUs and 3 GB memory is taken from the physical machine only, and one CPU, remaining 1 CPU and 1 GB memory is taken by operating system or hypervisor in order to run those softwares actually. So now previously, when there is no virtual machines, like entire like resource wastage is there, right here we, our resources like CPUs and memory is divided between virtual machines actually, like 3 CPUs and 3 GB RAM. Previously, in order to deploy 3 different applications on the physical servers, I need 3 different physical servers. But in the virtual machine, okay, one physical server, I can deploy multiple applications. Suppose this is one application, like one application, this is second application, and this is the third application. Now suppose, Here, in order to deploy multiple applications, I need to purchase multiple physical servers. But in this case, in one physical server only, I am deploying multiple applications. So my huge cost disadvantage that we have with physical servers is entirely reduced in case of virtual machine or virtualization, actually. Because see, here I am purchasing multiple physical servers, but here I am purchasing one physical server and deploying multiple applications on the as part of virtual servers, actually. So that is virtual server. Huge cost. The disadvantage of huge cost is gone in case of virtualization. This is virtualization, actually. Now, huge maintenance. Here we are maintaining different physical servers in order to deploy multiple applications. But in this case, in the case of virtualization, we will be having one physical server or one physical machine to maintain. Only one physical machine is required. So that huge maintenance is removed in case of virtual server, actually. Virtualization, if you are using this virtualization as part of AWS cloud provider or Azure cloud provider or GK cloud provider, that maintenance will automatically performed by AWS people itself. You no need to worry. That is the high reduction that is happened in case of maintenance. Okay, now disaster recovery, there is no disaster recovery that is there with the physical server. Right now, how the disaster recovery is there with the virtual machines or virtualization is, suppose if in AWS, what we'll be having is, we will be having something called auto scaling group. So all these three virtual machines are part of those auto scaling group. Okay, those auto scaling group, actually. Now, if one virtual machine has been deleted or crashed or anything happened to this virtual machine, a new virtual machine automatically comes up and our application will be automatically deployed on that virtual machine. So such kind of disaster recovery mechanisms are there with virtual machines or the cloud provider. So that the disadvantage that we have with the physical server, like no disaster recovery mechanism, has been removed in case of virtualization and virtual machines, actually. Now, the left out part is resource wastage. In case of the virtualization also, we have resource wastage. Suppose my application that have deployed on this virtual machine, let's think this is application 1. Let me take this one as app 1. Okay, this one as app 2, and this one as app 3. Okay, app 3. Okay, these are the three different applications. Now, first application is only taking one CPU, and 1 GB memory. Okay, this first application is taking 1 CPU and 1 GB memory, and the remaining CPUs and remaining memory is waste, right? So what are the remaining CPUs and remaining memory that is there with this virtual machine is 2 CPUs and 2 GB memory is remained out of this, actually, because 1 CPU and 1 GB memory is used by my application, and the remaining is 2 CPU and 2 GB memory. The resource wastage that we have with the physical server is also there with the virtualization, actually. So that is the disadvantages that we still have. This is the one of the reason why we go to Docker, and the other reason why the people has went to Docker is evolution of microservices in the industry, actually. So this is the first disadvantage that we have if we deploy our application as part of virtual machines. Is what is a virtual machine? Virtual machine is a, like, where we can only interact, we cannot see or we cannot touch it. Okay, the physical, on top of physical machine, the virtual machine will be installed. Okay, that's a virtual machine, actually. So that's the thing. Now let me go here, and what are the disadvantages if we deploy the applications of virtual machine? Let me put it here. Disadvantages of deploying applications on virtual machines. Okay, disadvantages of deploying applications on virtual machines. Now, first disadvantage that we have if we deploy our application on the virtual machine is the resource wastage is still there as part of virtual, like physical machine also there, but as part of virtual machine is also there. Resource wastage. Okay, wastage. And the second reason why we go to the Docker is the evolution of micro services. Okay, the evolution of microservices. Because of these two reasons, there are many reasons, but let's stick to these two. Because of these reasons, why we go to the other reasons were like easy maintenance, and with less amount of time you can deploy, the less amount of time it takes to application to come up in the running state. So such kind of easily you can check the logs. So there are different things that why we go to Docker. But yeah, let's stick to this. Resource wastage is one of the reason why we go to Docker, and the evolution of microservices is one other reason that why we are going to Docker actually. Now, how Docker is structured in the same way. Okay, now let's take, I'm not taking the physical machine. I also take, oh, sorry, I am not taking the physical machine here. I am only taking the virtual machine, and this virtual machine is part of physical machine only like this. Okay, this part of physical machine only like this. This is a virtual machine. Inside the box is virtual machine, and the outside box is physical machine. Now let's take this as, this is the physical machine, and this is the virtual machine. Let me think of, okay, this is a virtual machine that we have. On this virtual machine, we will be having some guest operating system. Okay, I have drawn here 3 different virtual machines, but as an example I am taking the one virtual machine here. On the physical machine, these layers will be still there, like operating system will be there, hypervisor will be there. But yeah, I've already explained here, that's why I did not put here, but yeah, that layers will be there. On top of that, virtual machine will be there. Okay, on inside the virtual machine, we'll be having guest operating system, guest OS. Okay, guest OS. Okay, now that's a guest operating system that we have actually. Now the guest OS. Now on the top of guest OS, what we will install is, we will install Docker. Okay, we'll call the Docker as a container runtime engine. Okay, what is container runtime engine? Why we'll call it as that, like we'll discuss in the course, but we will install Docker on top of guest OS. Let me put it here, Docker here. Let me put like this. Okay, this is Docker on top of guest OS. We will install actually. Now on top of Docker, we are going to create, we are going to deploy our applications. This one is one application, this one is another application, this one is another application. Now if my virtual machine has like in the same example, I am going to take 3 CPUs and 3 GB memory. Suppose let me take this. Okay, three CPU, three, or let me remove this. 1 second. Let me take this. I have 3 CPUs, 3 CPUs. Okay, now and 3 GB memory, 3 GB memory for this virtual machine. In the same way, I have taken like that one. Now here entire resource is properly consumed. Okay, this is the application one. Let me take this as app 1. Okay, now this one as app 2, okay, now this is as app 3 actually. Now this application 1 will be consuming 1 CPU. Let's think my application 1 only requires 1 CPU and 1 GB memory, 1 GB memory. Okay, this is the application 1 that is been there. Let me copy this and let me put it here as well, and let me put it here as well. Okay, now entire resource, like entire virtual machine, entire resources for the virtual machine, 3 CPUs and 3 GB RAM is properly consumed by my applications. Now previously if my application is consuming 1 CPU and 1 GB memory, and the 2 CPUs and 2 GB memory out of the resources that is having with the virtual machine is left out, right? So here in the case of Docker, entire resource is properly consumed, and there is no dependency for our applications to on the operating system of virtual machine. So this is the this disadvantage that we have with virtual machines or virtualization. If you deploy the applications of the virtual machine, or virtualization is gone as part of Docker, actually entire resource is properly consumed. Okay, that's a reason why we go to Docker. And the other reason is evolution of microservices. So if you have any questions you have, please ask. Okay, any questions you have? Any questions anyone has? Is that okay? Are you able to understand, or shall I explain from scratch? Hello? Can anyone speak, please? Okay, okay. Anyone has any questions, please?
No question on my side yet. No question for now.
This whole thing is based upon creating, allocating memory and RAMs, virtualization. This whole Docker containerization concept is based around that, right? Is that what you have to understand on a from a primary or base perspective? Hello. Did we lose the presenter?
Yes.
Can you able to hear me? Anyone have any questions, please?
Hello.
Hello?
Yeah, we lost you for some time actually.
Sorry, actually, this is my network issue. I've rejoined one more time. Sorry for that. Any questions, please?
No, just a base fundamental question. Now, this whole concept of this Docker and Kubernetes and all of that is based on virtualization, trying to gather or allocate memory, memory on the spaces, uh, RAM size, and all of that, and then managing them, right? So that's the whole idea of being able to be able to partition and proportionate to the partition and the usage, being able to manage that. That's the whole idea from
Yes.
this perspective.
Yes. Yeah, that's the thing. And because you need to understand what the different problems that is there with the previous technologies, why the Docker has come into picture. That's a whole idea, as you said. Yes.
Okay.
Yeah.
And mostly it is the commands, the CLI is all based on Unix type, right? Unix format.
Yes, see, because in the industry as well, because the people will be deploying their applications on the Linux machines only, not directly Windows. So based on the requirement, mostly 95% of the people will be deploying their applications on the Linux machines. That is why we are going to use the Linux things, because you need to understand what are the problems if you deploy the applications on the Linux machines only, so that it will be very easy for you in the industry in order to debug the problems, right? So that's the thing. We are going to use the Unix only. We are going to not use the Windows, but the same commands which we are going to discuss will also work for Windows. If you install Docker or whatever it is, the same commands will be there for Windows, but the installation part will be different for Windows. That's it.
I mean, with the Windows hypervisor and a lot of things in place. So those, I mean, of course, there is a Windows subsystem for Linux, which is kind of Linux under the Windows hood. But
Yes.
apart from that, it should also be manageable within Windows, right? There is a lot of Windows servers.
Yes, it will also be manageable within Windows, but in order to get your real-time experience, I'm suggesting you to create an AWS server. That's a ultimate thing. That's the reason why I'm suggesting you to create an AWS server. That's it. That is manageable for Windows as well, as you say. You're right.
All
Yeah. No, let me share my screen one more time, please. Sorry for the inconvenience. I'm like I went like my network is not proper. Sorry for that. Okay. Now I am able to join now. I hope my screen is also able to like you can also able to view my screen. Okay. Now that's the thing. Now this is the disadvantages that we have seen with the Docker, and why the evolution of Docker, and what are the disadvantages that we have with the physical server virtualization, why the Docker is evolved. So that's the thing what we have went through right now. I need to show you one thing. Okay, you need to create an account here, like for storing the Docker images. hub.docker.com. Okay, hub.docker.com is the registry where your images, where your applications will be stored. Actually, your Docker images, what is Docker image I will discuss, but your applications or your Docker image will be stored as part of this registry, hub.docker.com. How to create an account here? Let me sign out and show you. It's a free account, it's an open source one. Now click on sign up. Okay, click on sign up here. Now give your email, username and password, and some like that's the thing. Just click on sign up, and if you want to follow auth, click on continue with Google, so that you will be able to log in with the help of your account, Gmail account. That's also you can do GitHub or Google. So you need to create this hub.docker.com account, so that your images, your custom, you are going to create a Docker images, right? That will be stored as part of this hub.docker. As part of this hub.docker.com. Actually, that's you need to create this account, need to be created. Okay, that's the thing. Now before that, now one more thing you need to create is an AWS account. Okay, how to create an AWS account? Let me show you. Let me go here, AWS amazon.com. Now here you will be having, click on sign into the console. Maybe I'll be directly logged in. Let me see that. Yeah, because I've already logged in here, that's why I'm directly logging in. Let me log out from here, so that yeah, I will not be able to log in. Now here we have sign into the console. Once you searched for in the browser, please search for aws.amazon.com. Search for that. Okay, once you search for aws.amazon.com, click on sign into the console. Click on sign into the console. In this screen, you are going to see create a new AWS account. Okay, create a new AWS account. Click on that, create a new AWS account. Click on that. Okay, now just click on that. Just wait for the other screen to appear. Okay, now you need to give your email address. Okay, that's an email address you need to give, your unique email address. Okay, that you need to give, and the AWS account name actually you need to give. Okay, AWS account name, and it will be asking for you to verify the email address, and you need to go further steps actually. So it is as easy as you are creating your Facebook or Insta accounts. Now it will ask for you some the details like your username and your name, last name, first name, and the related things. And it will ask for setting the passwords, and yeah, it will ask for confirming the password. And the important step that it will ask is for your account details, bank account details. Okay, why it will ask for your bank account details is it will to verify whether it is you or not actually. So it will ask for your bank account details. You need to give your card information there. It will be debiting 2 rupees from your account, and it will be recrediting that 2 rupees again, because it once verified, it will be recrediting that money that to your bank account again. So once that's the important step that I want to tell you. And once that step has been completed, it will take 24 hours for you to for in order to activate your account. They will take 24 hours to activate your account, because they in the documentation they mentioned like that they will not actually take 24 hours, they will take very less than that. But they'll the maximum amount of time they will take, if your entered information is correct and entered things are correct, so they'll take 24 hours in order to do that. And the other thing is, once if you want to your account to be immediately activated, you can also contact AWS support team in order you to activate your account immediately once you created your account, so that you can directly log into your portal actually. Now that's how you need to create. It's as easy as creating Insta or Facebook account. Because I'm not having the unique email address here, I am unable to show here, but yeah, it's very easy. Just enter the details whatever it asked. The important step is to ask for your account details. That's it. That's the thing. Now once you created your AWS account, click on sign into the existing AWS account. You can click on that. Okay, just I've clicked on that. Now we have two types of users here, root user and IAM user. There are different types of user that we call it as root user and IAM user. Now do not modify this, because by default it is root user only. Now give your email address here, give your email address, click on next. Okay, click on next. Now give your password here, which you have entered when you are creating your uh, AWS account. Just give that password here and click on sign in. Okay, click on sign in. Now once you clicked on sign in, you will be having this type of screen. Okay, this type of screen. This is a screen, first screen that will be appearing to you in order to this is the first thing that will be appearing to you actually. Now we will be having different types of services. We will be having different types of services in the AWS. You can see these are the different types of services that we have. That's none of our business, but yeah, I'm showing that one. But yeah, it's okay. Now yeah, you need to regularly see the cost details, whether you are costed or not. See, that's 1 year. When you create your AWS account, 1 year it will be free, but it entirely is not free until certain limit is free for you. Okay, if you are using EC2 machines, 750 hours is free for 1 month. Okay, so that's what they designed. Okay, 1 year they'll tell us free, but it is uh, not if you cannot use all the things, and you cannot use high amount of machines, something like that. But until some particular limit is there, until that limit it is free actually. We will fall under that limit only, we will not go beyond that limit. Okay, now you need to regularly check the cost details here, because you whether you costed or not. Yeah, that's a you need to regularly check the cost and usage. You can see here like the cost details here. Now past month, current month, last month, something like that. So that's you need to regularly check that actually. Now that's the thing. Now once you logged into the console, you will be finding something called search box. Okay, you will be finding something called search box. Here you need to search for EC2. You need to search for EC2. This is one of the service where we can create our virtual machines actually. That is the EC2 service. Now click on that EC2, click on that EC2. Now this is the EC2 machine. Okay, this is the EC2 service actually. Now go down to the bottom, you will be finding something called key pairs. Okay, where is that key pairs? Yeah, network and security. Under the network and security tab in the left side, under the network and security, you will be finding key pairs. Click on that key pairs, click on that key pairs. Now in the key pair section, in your case, because you have created for the first time, you will be not finding any key pair. But in my case, I have already created a key pair for my regular usage, so I'll be seeing these key pairs. But in your section, in your case, you'll not seeing that. Now you need to create a key pair. How to create a key pair is using create a, click on create a key pair like this. Click on create key pair. Now once you click on that, you need to give a key pair a name. Actually, why the key pair is required is, now we have virtual machine. Okay, we have virtual machine. Let's think this is the virtual machine. This is a virtual machine. Now we need to log into this virtual machine, right? We need to enter into this virtual machine to perform some actions, right? So we need to create a containers, we need to create a images, something like that, right? In order to do such kind of actions, we need some password that in order to enter this, in order to enter into this virtual machine, so that password is called key pair. Okay, now give a key pair a name. Let me give something name. Give key pair a name. Now do not modify anything. Click on create a key pair. Click on create a key pair. Once you clicked on this create a key pair, it will ask you to download a file. Okay, it will ask you to download a file. It will automatically download a file. Just you need to click on okay, that's it. That will download a file. Keep that file in a safe place, because that file contains your secret or password in order to log in to your virtual machine or virtual server. Actually, now that's the thing. Now I already have a virtual like key pairs here. I am going to use that key pairs, existing key pairs that I have. Actually, you need to create the new one because your account may be the new account. Okay, now go here. Now that is a key pair creation. Now once you created a key pair, you need to create a virtual machine, right? Now go to left menu. This is a menu that we have, right? So click on instances. Click on this instances. Now you need to create a new virtual. This is the instances screen. What is instances? Instances means virtual machines. As part of this diagram, this is our virtual machine, right? These three are our virtual machines. These are called instances in AWS. These are also called EC2 machines, instances, virtual machines, virtual servers. There are multiple names for that. Actually, these are called instances. Okay, now physical machine will be maintained by the AWS people only. We are not going to maintain the physical machines. Physical machines will be there with the AWS people, and we are going to maintain the virtual machines inside the physical machines only. Now how to create a virtual machine is, in your case there will be no virtual machine, zero virtual machines will be there in your case. But as I've already created a virtual machines, so my virtual machines will be showing like this. Actually, now that's the thing. Now these are the virtual machines that I have. How to create a virtual machine? You need to click on launch instances. Okay, you will be finding launch instances button or here at the top of the screen. Now click on this launch instances and give instance a name, a virtual machine a name. Let me give Docker test. Okay, I am giving the name as Docker test, or let me give that K8s test. Okay, 1 second. Okay, because yeah, K8s test, just name it. You can name any with any name you want. Okay, I want to use Ubuntu operating system. I want to create a Ubuntu operating system inside that. Now do not modify anything. Do not modify anything. Click on here. We have different types of instances, right? Click on, like, you can use this t2.micro for your case, because this t2.micro is free tier eligible. You can see free tier eligible. You can use this only, but I don't want to use this. But I need to create multiple containers, right? It requires a lot of CPU and lot of memory, right? I need to use high capacity virtual machines. Actually, so this, if you use t2.micro, one vCPU will be there and 1 GB memory will be there for that virtual machine. Actually, so I want to use t2.medium virtual machine. This is a virtual machine I want to use. Now in the key pair section, you need to select your key pair. You have different, you previously you created a key pair, right? Just I have shown you how to create a key pair, right? That key pair will be appeared here once you created there. Now you need to select that key pair by clicking on the drop down list box. The key pair will be appeared. Click on that, select that key pair. Actually, now go down to the bottom and you need to select an existing security group under the network settings. You need to select existing security group, and once you select this existing security group, you will be finding a drop down list box. Click on the drop down list box and select the default security group, this one. Just select that. That's it. Now do not modify anything. Do not modify anything other than this. What are the things that you need to give? You need to name that virtual machine. You need to click on the Ubuntu. That's it. You no need of modifying this instance type also. Yeah, it will work for you. And you need to give the key pair. I need to give the select an existing security group and select a security group. I need to just launch instance. You need to click on launch instance. That's it. That's it. Now your instance is launched. You can see it is in pending state. This is an instance is in pending state, is going to be the running state soon actually. So that's how you need to launch an instance. Okay, let it complete. Okay, let it come into running state, so that, yeah, it has come into running state. It should be 2 by 2 health checks passed here. Let it complete initializing. Let it complete initializing. It is initializing state. Yeah, that's it. Let it be. We can able to log in now. Select your virtual machine. I have created this virtual machine. Just select that by clicking on this checkbox and click on here. You will be finding connect. Actually, just click on connect. Do not modify anything here. Do not modify anything here. Click on connect. Okay, you are logged in. Just wait. It is logging into the virtual machine. There are many ways to not in order to log into the virtual machine, but this is a common way for everyone actually, because that's the thing. So you have logged in to the virtual machine now, because I have shown in the diagram, right? This is a virtual machine. You need to first log into this, right? So you have logged in to the virtual machine now this is a virtual machine. I have logged in now. Sudo, you need to switch to root user. Sudo su hyphen. Let me clear the screen. This is the root user. You need to switch. Now you need to install Docker software in it. Now, in order to for your easy purpose, I have collected the installation of Docker commands. I have put somewhere here. Now, let me install one by one. Okay, let me execute one by one here. Let me put it here. Let me update the packages. This is just an installation. No need of worrying anything. Just update the packages. Okay. Let me execute this one. Let me execute this one. Now, the other command is this one. Now, the other command is this one. Let me put it here. Just installation of Docker. That's it. No problem. Yeah. The other command is sudo apt update -y. Updating the packages. And this is the thing you need to do. 1 second. Let me complete. It has been completing. 1 second. This is the thing installation. It is installing Docker. Yeah, it now install docker on my virtual machine. How to check whether the docker is in running state or not? In the Linux command systemctl status docker is the command that we have. Okay, you need to see, once you execute this systemctl status docker, you should see the docker should be in active and running state. That means docker is in running state. Actually, that is how you need to find out whether the docker is installed or it is in running state or not. Now you can see the docker is in running state. Actually, this is the installation of docker that you need to perform. Actually, now let me clear the screen. Yeah, now that is how you need to install docker. I will be sharing this document with you people so that you can install docker in your local machine, or like, sorry, in your virtual machine, and you can practice the things there. Okay, any questions you have with creation of AWS account and creation of virtual machine with a key pair, as well as logging into the virtual machine and installation of docker? Any questions you have with those things? Anyone? If you don't have any questions, please put your that comment in chat that you have no questions, please. Any questions, or please put your message in chat. Is that okay, or shall I tell one more time? Hello, are you people there? Can you people able to hear me?
Yes, sir.
Okay, any questions you have, please? Oh, please give me some information so that I'll be understanding whether I need to explain one more time or not.
It's good on my side. I don't know about all the.
Mhm. Is that okay from your side?
Yes, yes. To me, it's good. I don't have any issue with that.
Okay.
Yes, sir.
Yeah, any others you have? If you have any questions, please ask. Do not hesitate to ask. Okay, that's a thing. Actually, now let's go further. That is the installation of docker. Actually, now what we are going to see further is about the let me go here. One second. Now we need to understand some of the terminologies in Docker. Actually, need to understand some of the terminologies in Docker. So let's understand one by one. Suppose we have different terminologies that we have in Docker. First terminology that we have in Docker is first terminology that we have in Docker is Docker daemon. Docker daemon. So the Docker daemon is like the background process in the operating system terminology. What is daemon? Daemon is the background process that is running inside the virtual machine, right? So in that, for the Docker also, there will be something called daemon which will be running inside the like background process, as a background process. If you see here, systemctl status Docker. Okay, there is a background process that is in running state that is represented as daemon. Okay, that's a daemon actually. Let me go here, and yeah, that is a daemon. Let me put it here. Background process that is running belongs to Docker is called daemon actually. No, that's a daemon. No, the other terminology that we have is Docker container. Docker image. Before going to Docker container, let's go to Docker image. See, Docker image is a binary. Suppose if you want to play a game, right, you are going to install something called exe file, executable file from the internet, and you are going to double click that file, right? So that file will be executed as a game so that you can play a game. That binary in which your game contains, your that file will be downloading. In that file that your game contains, but it is not in running state. When you are double clicking on that file only, your game will be started, right? So that binary is called an Docker image. Inside the Docker image, our application will be there, but it will not be in running state. That is the binary or the Docker image that we call it as. Okay, that's a static or binary. Okay, let me put it here. It's a binary where our application is present but not in running state. That is a binary. It is a binary where our application will be present inside the Docker image. What will be there? An application will be there, but not in running state. Okay, that is a Docker image. Okay, that's a thing actually. Now the other terminology that you need to know is Docker container. Okay, Docker container. Now, what is Docker container? The running instance of this image is called Docker container. Suppose in the game, right, you will be installing a file. As I take an example, double click when you double click on that file, your game will be in running state, right? In the same way, when you run the Docker image, that will be running as Docker container. What that container contains, your application will be in running state. What's the difference between Docker image and Docker container? In the Docker image, application will be there but not in running state. But inside the Docker container, application will be in running state. You will be using this Docker image in order to run that image as a Docker container. Using the Docker image only, you will be running in Docker container where the application will be in running state. The running instance of Docker image is Docker container. Okay, that is a Docker container actually. Now, what is the fourth terminology that we have is Docker registry. Docker registry actually. This Docker registry, what is Docker registry means? Docker registry is the storage where we store our Docker images actually. From the Spring Boot application, we will be creating, or from the Java or Python application, we will be creating a Docker image. You need to have some place to store that Docker image, right? So that is called Docker registry. There are two types of Docker registry, right? There are two types of Docker registry. One is public Docker registry. Public Docker registry. In this public Docker registry, if you store the images into public Docker registry, means that images will be accessible to everyone in the world. Anyone in the world can be able to download your image, and anyone will be able to use your image actually. So that will be if the image is stored here, image is stored here, the image will be available to everyone in the world. That is public Docker registry. And the second Docker registry that we have is private Docker registry. That is the private Docker registry. Now, private, let me enter down. private Docker registry. If you store your Docker images in the private Docker registry, only you or whoever have access to that registry, only those people only will be able to access the images that are present in the private Docker registry. That is the restriction that we have to that Docker registry actually. So if you store your applications, your Docker images inside the private Docker registry, the people who has the access only will be able to access the images, the Docker images present in the private Docker registry. It is private to organization and to you. Okay, in the industry, people will not be storing their images to the public domain. Like in the public Docker registry, they'll not store. They will use the private Docker registry in order to store their images. Actually, that is a private Docker registry. That is a next that's the terminology you need to know. That the fifth terminology that you need to know is the Docker client. Okay, Docker client. Okay, Docker client. Actually, what is Docker client? The client, the Docker client means from where you are running the Docker commands is called Docker client. Suppose this is a virtual machine, right? From where we are running Docker client, right? Docker images, I am running the Docker commands from this virtual machine, from this terminal, right? What is a terminal? It's a command prompt in your Windows, right? So from the terminal you are running the Docker commands. That is Docker client. Actually, from where you are running the place where we are running Docker commands is Docker client. Actually, that is Docker client. Now sixth one, that is sixth terminology you need to understand is called Docker host. Okay, this is a you need to understand what is Docker host. The machine, the virtual machine on which the Docker is installed is called Docker host. See, in this virtual machine, this is a virtual machine on which we install Docker, right? That is why you can see systemctl say status Docker. This is a systemctl status Docker is a command that we are executing, right? So that means the Docker is installed on this virtual machine. So this virtual machine is called Docker host. Okay, this virtual machine is called Docker host. Let me clear the screen. Okay, now for this virtual machine we have different names right now: virtual machine, virtual server, instance, EC2 machine, Docker host. All the names comes under this virtual machine only. This has different names right now. The machine on which Docker is installed is Docker host. Actually, so that is the Docker host that we call it as. So that is the terminologies. There are many other terminologies, what is Docker volumes and what is Docker networking, but we'll see in the Docker course. But these are the initial things that you need to know. First, you need to know the Docker commands and Docker daemon, and in order to know the Docker commands, you need to know Docker daemon, what is Docker image, Docker container, Docker registry, private Docker registry, public Docker registry. Under the Docker registries, you need to understand the Docker client and what is Docker host. We have seen all these terminologies, why we call it as with those terminologies. So that's a thing. Actually, if you have any questions, please ask. If you have any questions, do you have any questions regarding terminology or anything today's class? Please, anyone has any questions? Anyone have any questions, please? Yeah, if you don't have any questions, okay, if you have any questions, please ask. If you don't have any questions, we are going to end this class today because it's time, and we are going to continue tomorrow with Docker architecture. Okay, we are going to continue tomorrow with the Docker architecture and some of the use cases, how to pull the Docker images, how to create a containers out of those Docker images, how to access the applications that are there inside the Docker containers from the web browser. Such kind of use cases we are going to handle tomorrow. Actually, at the same time, 9 a.m. will be there, but please make sure this class will be shifted to 8 a.m. morning. Okay, so every weekend, actually, that's a ultimate thing I want to mention. From the next weekend itself, it is moved to 8 a.m. Okay, if you have any questions, please ask. Okay, if you don't have any questions,
What is the duration? What will be the duration of the class from 8 a.m. to
8 a.m.
around
to
10:30?
10 to 10:30. Yes, you're right.
8 a.m. to 10:30
Yeah,
approximately.
yeah, yes.
Okay. And it will be over, including this weekend, 5 weekends total in total.
Yes, yes. It's go to 7, okay, not 5. Okay.
Sorry.
It goes to 7 weekends.
Okay. So including this weekend,
Yes, including this
whole
weekend.
weekend. When I say weekend, means Saturday, Sunday both, right?
Yes, Saturdays and both. Yes.
7 weekends. Okay.
Mm.
So today you mentioned about public and private registries for Docker, where images can be kept, which are either open to everyone or it is private to your organization or to yourself as an
Yes.
individual.
Uh-huh.
And then these images can be used anywhere across. If somebody wants to capture that bundle or image to use some of his utilities, then they can.
Yes,
So,
yes. The public Docker registry. Yes, you're right.
and we can create, I can create anybody can create an image, and I have this option to make it public or
Yes,
private.
yes. You have an option. Okay. Yeah, you can store wherever you want because it's your image.
Hmm. And if somebody is aware of what the image name, etc., is, they can use that if they have
Yes.
to. Just like any, it's similar to any package, NuGet package or anything, right? So jar file or repository where I put our phone npm,
Yes, yes.
similar to npm.
Yeah, yeah. It's similar to that, but those are dependencies. But this is a Docker image along with the dependencies. Yes.
Okay. All right, I'm good for today.
Okay, okay. Thanks for that. Yeah. If no questions, if anyone has any questions, please ask. If no questions, please go ahead and register for the course. Tomorrow we are going to see the concepts, Docker, whatever I told previously, Docker architecture, and some of the use cases, how to access the applications from which are running inside the Docker containers from your web browser. Such kind of use cases we are going to see, and some of the flags, explanation of flags, and some of the explanation of Docker commands. So all those things we are going to see from tomorrow. Okay. So yeah, this you'll be getting a good knowledge out of this course, and whatever it is, you will be getting the industry standard things in this course, and the thing, yeah, the projects is also designed in that manner. Yeah, that's the thing. Yeah, everything will be perfect, and please go ahead and register for the course, and we'll speak tomorrow, and we'll meet tomorrow if you have
I have
yeah.
one more concern about the schedule. Do you have like any oncoming batch in the evening, IST?
No, we are going to have weekdays batch from Monday. Okay, it will be from 9:30 to 10:30 a.m. only. Evening batches is not being scheduled as of now with me, and morning batch only is there because I am working is an office in the evening. Up to my office will be going up to 10:30. It's not possible for me to take any evening, but the weekdays batch is also contains the Jenkins. Okay, so that's a extra thing you will be getting in weekdays batch.
But do you have any plan in instead of weekend? Do you have any like uh in the daytime, like in the weekday? No, right?
Yeah, I told you, right? We have a weekdays batch is going on from tomorrow, not tomorrow, Monday. That is 9:30 a.m. to 10:30 a.m., which also includes Jenkins, Docker, Jenkins, and Kubernetes. Not
Okay,
Jenkins
okay.
is not there. Yeah, yeah, that's the thing.
Docker, Jenkins, Kubernetes. Okay, okay.
Yeah,
All right. Thank you.
thank you. Yeah, thanks for the day. Thanks for joining sessions. Please go ahead and register for the course, and we'll meet tomorrow. Thank you. Bye.